I welcome you all for this lecture series on deep learning. In this lecture, we are going to discuss about an important topic in deep learning, that is model evaluation. First, let me tell you why it is essential in deep learning. Model evaluation is essential in deep learning because training accuracy alone does not tell us whether your model truly understands the data or can perform well on new unseen inputs. A deep learning model may memorize training examples instead of learning general patterns, which leads to overfitting. Evaluation methods such as validation loss, test accuracy, precision, recall, FN score, ROC curves, and confusion matrices all will help us measure how well the model generalizes beyond the training data set. Evaluation is also necessary to compare different models, architectures, or hyperparameters and choose the best one for deployment. Without proper evaluation, we cannot know whether increasing layers, changing learning rate, or using regularization accuracy improves performance. In real world applications such as medical diagnosis, autonomous driving, or financial prediction, poor evaluation can lead to serious consequences because an apparently accurate model may fail in practice. Finally, model evaluation helps ensure reliability, fairness, and robustness. It allows us to detect bias, data imbalance issues, and sensitivity to noise. In short, evaluation is what transforms a trained neural network into a trustworthy and usable intelligent systems. We'll see one by one. Just the introduction about the model evaluation. First, the model evaluation measures how well a deep learning model performs. Model evaluation model is the systematic process of assuring the performance of a trained deep learning model. After training a neural network on dataset, we must measure how effectively it has learned patterns and relationships. Evaluation helps determine whether the model is making accurate and meaningful predictions, and it will check performance on unseen, that means new data. A key purpose of evaluation is to test the model on data that it has never seen before. This ensures that the model is not simply memorizing training examples but is capable of generalizing learned knowledge to new inputs. Performance on unseen data reflects real world capability and it ensures model generalization ability. That means generalization refers to the model's ability to perform well on new unseen data sets. A well generalized model captures underlying patterns rather than noise. And evaluation metrics helps us measure whether the model generalizes properly. The answer for this is how good is my model? How you are going to answer for this? Ultimately, model evaluation provides a quantitative answer to the question, how good is my model? It gives measurable values such as accuracy, error rate, or AUZ, which indicates the model's effectiveness. Next, why model evaluation is important. And the high accuracy is not equal to good real world performance. This means what? A model may achieve very high accuracy on training data, but still perform poorly on new data. This happens because the model may memorize training examples instead of learning general patterns, and it will detect overfitting and underfitting. That means evaluation helps identify whether the model is overfitting. Overfitting means what? Too complex, or underfitting means too simple. Comparing training and validation performance provides clear insights into these issues and it will help measure different models. When multiple models are trained, evaluation metrics allow us to compare their performance objectively. The model with better validation or test performance is chosen. It ensures reliability before deployment. Before deploying a model into real world systems like healthcare, finance, or proper evaluation ensures reliability and safety, and it improves decision making in model selection. Evaluation metrics guide data scientists in selecting appropriate architectures, hyperparameters, and optimization strategies. Next, data. What do you mean by data splitting? We have the training set. It means unused to train the model. The training data set is used to update a model weights using optimization algorithms like gradient descent. The model learns patterns from this data set. What do you mean by validation set? Validation test is used for set is used for hyperparameter tuning. The validation sets helps adjust hyperparameters such as learning rate, batch size, and number of layers without touching the test data. Next, test set. It is used for final evaluation. The test set is used only once after training is complete to provide an unbiased estimate of real world performance, and it prevents data leakage. Separating data sets ensures that no information from validation or test data leaks into training process. Next, it ensures fair performance estimation. By maintaining separation, we obtain a realistic and fair measurement of performance. Next, the types of evaluation matrices or classification metrics. This means it is used when output is categorized. That means if you are using the Gmail, whether it is a spam or not spam. Examples including accuracy, precision, recall, and FN score. Next, another metric is the regression metrics. It is used when the output is continuous. Example, house price prediction. Example include MSC, RMSC, and R square. That we'll see later. And ranking matrices. It is advanced cases. It is used in recommendation system, that is mainly in AI, and search engines such as precision at K and mean average precision. Next, performance versus computational efficiency. Evaluation may also consider speed, memory usage, and inference time. And it is the other metric is the specific metrics. Some applications require specialized metrics such as Dice coefficient in medical imaging. Next, the accuracy, the first metric, it is used for the classification. It measures the overall correctness. Accuracy calculates the proper proportion of correctly classified samples out of total samples. The formula for accuracy is equal to correct prediction divided by total number of predictions. It divides the number of correct predictions by total number of predictions made, and it is simple and easy to interpret. Accuracy is intuitive and widely used because it is easy to understand, and it is not suitable for imbalanced data. That means in data sets where one class dominates, accuracy can be misleading. The next matrix is a confusion matrix, and here it is used for the performance. It is being given by performance summary table. Confusion matrix provides a complete breakdown of prediction results. True positive means here correctly predicted positive cases. True negative means correctly predicted negative cases. False positive means incorrectly predicted positive cases. False negative means incorrectly predicted negative cases, and it helps analyze the model errors. It allows detailed analysis of mistakes and helps derive other matrices used to calculate precision and recall. Next matrix is precision. It measures the correctness of positive predictions, and precision tells us how many predicted positive cases are actually positive. The formula for this is predictive equal true positive divided by true positive plus false positive. And here it divides the true positive by total predicted positive values. It is important when false positives are costly. It is useful in fraud detection when false alarms are expensive. The example is the spam detection. In email, if emails are incorrectly marked as spam, important messages may be lost. That is main drawback of this. Next metrics is the F1 score. The recall, that means sensitivity. It measures the ability to detect active actual positives. The formula for this is true positive divided by true positive plus false negative. Here, true positive divided by true positive plus false positive. Here, false and negative we have to take into account. There's the true positives by total actual positive. And important, it is very much important when false negatives are dangerous. Critical in medical image diagnosis where missing a disease is harmful. And example is disease detection. High recall ensures most patients with the disease are identified. Next metric is the F1 score. It is a harmonic mean of precision and recall. F1 score balances both metrics. The formula is given by it uses harmonic mean to penalize the extreme balance. F1 is equal to 2 into precision in recall divided by precision plus recall. And it is useful when both false positive and false negatives are matters. It is useful for imbalanced data set. It provides better performance insight than accuracy. And the next one is the ROC curve, region of ROC curve and AUC, area under ROC curve. Here the ROC curve is the given by it is been plotted between plots true positive versus rate versus positive false positive rate. It has been plotted between true positive rates versus false rate. And AUC means area under ROC curve. And the AUC value is 0 to 1. And high AUC means better classification separation. It is used for the binary classifications. And the next metric is the next metric is mean absolute error. We will see regression matrices mean absolute error MAC, mean squared errors, root mean squared error, and R square error, measure prediction error, magnitude. This we'll see one by one. Next. And the mean square error means the formula is given by 1 by n summation of actual minus predictor square. And it penalizes the large errors. It is common loss in deep learning and it is used in regression problems. Next, root mean square error, RMSE, is equal to root of MSE. It is same unit as targeted variable. It is easy to interpret and it is sensitive to large errors. And R square error is given by measures variance explained by the model. R square error is given by the formula 1 minus residual sum of squares divided by total sum of squares. The range, the R square value is between 0 to 1 and the high value means better fit. The next metric is the cross validation. It improves the reliability of evaluation. And here we are using the concept of k-fold cross validations. It splits the data into k part, it trained k times, and average performances could be measured. It reduces the variance in performance metrics, performance estimations. Next, what do you mean by the overfitting? Overfitting means high training accuracy, low validation and test accuracy is being used. Model memorizes the training data alone and it gives us the poor generalization. What is the solution to overcome all those four drawbacks? Dropout, regularization, and more data. Underfitting means low training accuracy, low validation accuracy, model too simple, fails to learn pattern. The solution for all overcome to these problems are increase model complexity, train longer, and better feature representations. And the learning curves are plot training loss versus epochs, plot validation loss versus epochs, and deduct overfitting versus and underfitting. And we have to monitor the convergence behavior and it will help in early stopping. And the mode of comparison could be done by using same data set and same evaluation metrics. And we have to compare the validation and test performance. And we have to consider the computational cost and also use we have to select best generalization models. Next, this is the overall diagram for the performance evaluation metrics in the deep learning. The first part, what we should do is the data splitting. Here we have training data, validation set, and test data. In this case, the data set is divided into three parts. A training set, it is used to train the model. Validation set is used to tune hyperparameters and prevent overfitting. And the test set is used to evaluate the final performance of the model on unseen data. This ensures this part ensures the model generalizes well to new data. Next, evaluation metrics. Here we are using it for this could be used for the classification. These metrics measure how well the model performance. It is been measured by accuracy, that is percentage of correct prediction. Precision means how many predicted positives are actually corrected. And recall means how many actual positives are correctly identified. And F1 score is being used by this formula. This we have seen it earlier. It is used for harmonic mean of precision and recall, useful for imbalanced data sets. Next, confusion matrix. So this I have told you: true positive, false positive, true negative. TP means true positive, positive, false negative, true. So here the table that summarizes the prediction results. True positive means correct positive prediction. False positive means incorrect positive prediction. False negative means missed positive cases. True negative means correct negative prediction. It helps in calculating precision, recall, and other metrics. ROC, ROC curve versus AUC, area under curve. ROC curve plots a true positive rate versus false positive region of convergence. And AUC, area under curve, measures overall performance model. And high AUC means better classification ability. Next, see here you can able to differentiate this overfitting and underfitting. Overfitting model performs well on training data but poorly on test data. This we are calling it as the memorization. Underfitting means model perform poorly on both training and test data. It is too simple. The goal is to achieve balanced generalization. Next, regression metrics, MAE, mean absolute error. This is average absolute error. MSE means average squared error. RMSE means square root of MSE. And R square error means measure how well prediction fit the actual data. So coming into the overall summary, that this diagram explains the complete workflow of evaluating deep learning models, including data splitting, classification metrics, performance curves, error analysis, and regression evaluation. It ensures models are accurate, reliable, and generalization. If you are looking into this diagram, the whole performance evaluation could be understood. Hope so. Coming into the conclusion, it model evaluation ensures reliability in it is different tasks require different metrics. It avoid relying on accuracy. It always validate before deployment. It is essential step in deep learning pipelines. Hope everyone deeply understands about the performance evaluation in deep learning. The remaining things we'll discuss in the next lecture. Thank you.